Greek mathematician lives in cities spread over the entire region, from Anatolia or Italy and North Africa, but were united by Greek culture and the Greek language. The development of mathematics as a theoretical discipline and the use of proofs is an important difference between Greek mathematics and those of preceding civilizations. So, let's proceed to the philosophers in ancient Greece. First, Thales of Miletus was an ancient Greek pre-Socratic philosopher from Miletus in Ionia and Asia Minor. Thales was one of the 7 sages, founding figures of ancient Greece, and credited with saying "Know thyself," which was inscribed on the temple of Apollo and Delphi. In mathematics, Thales is the namesake of Thales' theorem, and the intercept theorem can also be known as Thales' theorem. Thales was said to have calculated the heights of the pyramids and distance of ships from the shore. Next is Pythagoras. Pythagoras was an ancient Ionian Greek philosopher and the eponymous founder of Pythagoreanism. His political and religious teachings were well known in Magna Graecia, and influenced the philosophers of Plato, Aristotle, and through them, the West in general. Pythagoras was credited with many mathematical and scientific discoveries, including the Pythagorean theorem, Pythagorean turning, the 5 regular solids, the theory of proportions, the sphericity of the earth, and the identity of the morning and evening stars as the planet Venus. It was said that he was the first man to call himself a philosopher, lover of wisdom, and that he was the first to divide the globe into 5 climatic zones. Pythagoras influenced Plato, whose dialogues, especially his Timaeus, exhibit Pythagorean teaching, Pythagorean ideas on mathematical perfection also impact the ancient Greek art. His teaching underwent a major revival in the 1st century BC among Middle Platonists, coinciding with the rise of Neo-Pythagoreanism. Pythagoras continued to be regarded as a great philosopher throughout the Middle Ages, and his philosophy had a major impact on scientists such as Nicholas Copernicus, Johann Kepler, and Isaac Newton. Next is Euclid. Euclid was an ancient Greek mathematician active as a geometry and logician. Considered the father of geometry. Siya daw po ay father of geometry, and he is chiefly known for the Elements treatise, which established the foundations of geometry that largely dominated the field until the early 19th century. His system, now referred to as Euclidean geometry, involved new innovation in combination with synthesis of theories from early Greek mathematicians, including Eudoxus of Sindus, Hippocrates of Chios, Thales, and Theaetetus, with Archimedes and Apollonius of Perga. Euclid is generally considered among the greatest mathematicians of antiquity and one of the most influential of history of mathematics. Next is Plato. Plato was an ancient Greek philosopher born in Athens during the classical period in ancient Greece. In Athens, Plato founded the academy and philosophical school where he taught the philosophical doctrines that would later become known as Platonism. Plato was innovator of the written dialogue and dialectic forms in philosophy. He raised problems for what later become all major areas of both theoretical philosophy and practical philosophy. His most famous contribution is the theory of forms, which has been interpreted as advising a solution to what is known as problem of universals. He is also the namesake of Platonic love and Platonic solids. His own most decisive philosophical influence are usually true to have been along with Socrates and the pre-Socratic Pythagoreans, Heraclitus and Parmenides. Next is Aristotle. Aristotle is the founder of peripatetic school, often used mathematics to illustrate many of his theories, as when he used geometry in his theory of rainbow and the theory of proportion in his analysis of motions. Much of the knowledge about of ancient Greek mathematics in this period is thanks to record references by Aristotle in his own works. Next is Archimedes. Archimedes was a Greek mathematician, physicist, engineer, astronomer, and inventor from the ancient city of Syracuse in Sicily. Although few details of his life are known, he is regarded as one of the leading scientists in classical antiquity, considered the greatest mathematician of ancient history. And one of the greatest of all time, Archimedes anticipated modern calculus and analysis by applying the concept of the infinitely small and the method of exhaustions to derive and rigorously prove a range of geometrical theorems. So, Greek mathematics and mathematician, numerals and numbers. Here are examples of numerals numbers. And this is example of numeral numbers. Makikita nyo po sa baba na 4,672 is nasa kabilang side po yung pinaka-translate niya to numeral numbers. So, paano nga po pala siya naging 4,672 is yung x is 1,000. Ang value ng x is 1,000. So, bali 4,000 siya, edi 4x ang ilalagay natin. So, yung h naman po is ang value ng h is 100. So, kailangan natin ng 600. Bali 6 na h yung ilalagay natin para maging 600 siya. Tapos, yung may makikita po kayo na parang ganon is, ang value po nun is 50. So, 'di ba? Kailangan natin 50 para maging 72. Tapos, yung dalawang triangle is ang value nun is 10. Kaya dalawa yung nilagay para maging 10 plus 10 is equal to 20. Tapos, yung dalawang I, ang value nun is 1. So, kailangan natin ng 2, kaya dalawa yung nilagay natin I kasi is 2. So, pag binilang mo siya lahat is 4,672 is the ancient Greek of alphabet. We all know naman na parang napag-aralan na natin siya nung elementary. Pero, hindi na natin siya matandaan kasi nga matagal na ganyan. But, ito po yung ng ancient Greek alphabet. So, the origins of Greek mathematics are not well documented. As yung na-report po namin the last time is, ayun nga po na, discuss ko nga po na, hindi pa po fully documented yung Greek mathematics. Kaya po, nasabi na not well documented kasi nga po parang kaya nga po ganito kaunti yung pinaka-history niya kasi hindi pa fully na document ng pinaka talaga na paano na gawa yung Greek mathematics, kung paano siya nabuo, ganun. And the most characteristic product of Greek mathematics may be the theory of conic sections, which was largely developed in Hellenistic period, starting with the work of Menacamus and perfected primarily under Apollonius in his work Conics. Ancient Greek mathematics was not limited to theoretical works but was also used in other activities, such as business transactions in land mensuration, as evidenced by an extant text where computational procedures and practical consideration took more of central role. So, thank you for listening and hope you like this video. Thank you.
So, good day everyone. I am April Dominic Chifazon from Bachelor of Secondary Education, major in Mathematics. So, today we will be discussing about the birth of the calculus. So, let's start. Okay, so let's start. What period covered when calculus invented, or kailan kaya or anong era ang nasakupan nung pag-invent or nung naimbento ang calculus? So it is generally believed that calculus is invented independently in the late 17th century by two great mathematicians, Sir Isaac Newton and Gottfried Leibniz. And during this era, ano-ano ang mga breakthrough in mathematics? In the late 17th century, it was a time, ito yung panahon daw ng mga great breakthrough in mathematics. And one of that is the invention of calculus of Sir Isaac Newton and Gottfried Leibniz. This is a new branch of mathematics allowed for the study of rates of change and help to solve problems in physics, engineering, and economics. So, during this time, ito yung pag-imbento ng calculus, which is sobrang gamit sa panahon ngayon. Kung saan in other various fields, nagagamit natin ang calculus. And the second one of the breakthrough in mathematics during this era or period was the discovering infinite series by John Wallis and James Gregory. This allowed for the calculation of pi, which is the equivalent to 3.14. Then, to greater precision than ever before, and as well as the other mathematical constants. And the third breakthrough in mathematics that nahanap ko sa internet or na research ko is the mathematicians such as Pierre de Fermat and Blaise Pascal, which was discussed in our previous topic with our professor in history of mathematics. And then these two mathematicians made significant contribution to the probability theory, laying the groundwork for modern physics. So this is the three breakthrough in mathematics. Also, René Descartes was also one of the most significant contribution during this period. He invented the Cartesian plane. Yeah, the Cartesian plane. He is the inventor of that. of that topic, of that plane in mathematics. Okay, next is let's read this most significant contributions of Sir Isaac Newton. It was said here, Sir Isaac Newton was the mathematician and scientist, and he was the first person who is credited with developing calculus. So, isa daw siya sa mga mathematician and scientist during this time na nakapag-invento ng calculus or credited with developing calculus. Second one is Newton's teacher, Isaac Barrow, kapangalan niya pa, said the fundamental the the fundamental theorem of calculus was present in his writings, but somehow he didn't realize the significance of it nor highlight it. So, sabi nung teacher ni Sir Isaac Newton na si Isaac Barrow na nakita niya daw yung fundamental theorem of calculus sa mga sinulat ni Sir Isaac Newton. Pero, hindi yun nare-realize ni Sir Isaac Newton. And hindi niya na-realize yung significance or importance of that writings, of that topic in his writings. Or, hindi niya nakita, realize yung importance, or hindi niya na-highlight kung andun pala yung present ng fundamental theorem of calculus. Is between 1664 and 1666, he asserts that he invented the basic ideas of calculus. In 1669, he wrote a paper on it but refused to publish it. He wrote 2 additional papers in 1671 and 1676 on calculus but wouldn't publish them. So ito pala si Sir Isaac Newton is mahilig magsulat. But during this time, hindi niya nilalabas, hindi niya pinapublish. But, dumating ang araw na na-publish ito. So, between 1664, it was said between 1664 and 1666, he asserts that he invented the basic ideas of calculus. In 1669, he wrote a paper on it but refused to publish it. Yung paper na sinulat niya noong 1669 ay na-publish noong 1711. And 40 years later, after nung sinulat niya yon. So, 42 years, imagine, sobrang haba nung panahon bago na-publish yung mga sinulat niya about mga basic ideas of calculus. So, di ba, he wrote another 2 additional papers, 1671 and 1676. And yung sinulat noong 1671 was published in 1736. 9 years after his death in 1727. 9 years naman ito. Yung sa dalawang additional papers. And then, noong 1676 na sinulat niyang papel ay was published in 1704. Okay, so none of his works on calculus were published until the 18th century. So, imagine, sobrang haba bago ma-publish yung mga gawa niya. But, he circulated them to friends and acquaintances. So, it was known what he had written. So, yung mga friends niya, nakakaalam kung ano yung mga sinulat niya. But, iilan lang, yung mga kaibigan niya lang and yung mga acquaintances. So, this wasn't just hearsay, and he used the techniques of calculus in his scientific work. Let's proceed to one mathematician that invented calculus. Okay, so here we are. Gottfried Leibniz was a German mathematician who developed the present-day notation for the differential and integral calculus. So, ito rin pala siya si Leibniz. Siya yung naka-discover or nag-develop ng notation for the differential integral calculus. Also, he wrote a paper on calculus that was entitled A New Method for Maxima and Minima as well tangents which is not obstructed by fractional or irrational quantities. It was 6 pages, extremely obscure, and was very difficult to understand. So Leibniz is also a philosopher, and his philosophy is important. And he invented an early calculating machine. Let's proceed to the next page. Sabi dito, Gottfried Leibniz also invented calculus somewhere in the middle of the 1670s. He said that he conceived of the ideas in about 1674 and then published the ideas in 1684, 10 years later. So, after that, our professor in History of Mathematics mentioned about the controversy about these two great mathematicians in controversy about the who invented the calculus. So here we are. The controversy between Newton and Leibniz. The consensus has not always been so peaceful. However, the late 16th saw fierce debate between the two mathematicians, with each claiming the other had stolen his work. So sabi dito, the controversy between Newton and Leibniz started in the later part of 1600s in 1699. Leibniz's statement of Newton, then as now, caused us to take notice of the importance of one great mind commenting on other. So, may comment siya about kay Newton. Sabi niya, taking mathematics from the beginning of the world to the time when Newton lived, what he has done is much better part. Okay. Then kay Newton naman, but when Newton began to realize that Leibniz had ideas of calculus, which he himself began to realize in the 1770s. So, nung na-realize daw ni Newton na si Leibniz ay may mga ideas din sa calculus, na-realize niya din nung about sa kanya nung 1770s na. So, late na. And Newton's response to ensure that he received the credit for a calculus was to write a letter to Leibniz. So, iniisip niya na para sa kanya ibigay yung credit ng nung siya ang magre-receive ng credit sa calculus, nagsulat to siya ng letter kay Leibniz. So, okay. So, Newton first developed calculus and applied it directly to the understanding of physical systems. So, si Newton daw, siya ang first na nag-develop ng calculus. And in-apply niya yung mga na-discover niya about calculus, in-apply niya agad yun sa physical systems. Independently or sa kabilang side, si Leibniz naman is develop the notations used in calculus. And to simplify, the basic math uses operations such as plus, minus, times, and division. Calculus uses operations that employ functions and integrals to calculate rates of change. So calculus is rates of change, study of change. Ganun. So, Newton tried to establish his priority in that fashion, but what followed were accusations that Leibniz daw is nakabasa ng mga nasulat niya. That is why, sabi niya, is yung nakabasa daw si Leibniz ng manuscripts niya bago makabuo ng yung sinasabi niyang conceive. Na-conceive siya ng mga ideas nung, what year is that? Noong 1674. Okay. So, but, okay. So, but since, yun nga, sabi, nauna si Leibniz na mag-publish ng work or mga sinulat niya. And, yung mga taong nakabasa, syempre, ang unang lalabas, makakabasa agad yung mga tao. So, paniniwalaan ng mga tao na si Leibniz talaga ang nag-invent or sumulat ng calculus. Sa kanya talaga lahat ng idea. And, sinasabi ng tao na si Newton daw ang nagnakaw ng ideas about calculus kay Leibniz. Okay, so, while they were probably communicating while working on their theorems, it is evident from early manuscripts that Newton's work stemmed from studies of differentiation, and Leibniz began with integration. So, magkaiba sila. And they thus reached the same conclusions by working in opposite direction. So, magkaiba sila ng mga work, mga manuscripts. But, yun nga, yung kay Newton's differentiation and kay Leibniz naman yung integration. Magkaiba sila, but they come up with different conclusion. They come up with same conclusion by working in opposite directions. So, kasi nga magkaiba sila ng studies nung pinag-aralan. Okay, so, ganun. Yun yung controversy kung sino talaga ang unang nag-invent ng calculus. Okay. Let's proceed to most famous philosophers and their contribution or works. Okay, so are we familiar of these two philosophers? So, let's discuss about these two. Kung sino ba talaga sila. Okay, so the first one was on the right side is René Descartes. René Descartes in 1596 to 1650. So, René Descartes is the father of modern philosophy. He was a mathematician, philosopher, and scientist. So, marami rin siyang ginagawa, which is, we can call polymath. Okay, so, he developed rules for deductive reasoning, a system for using letters as mathematical variables. So, siya yung mga nag-develop ng mga rules sa deductive reasoning. And then, in mathematics sphere, his primary contribution was bridging the gap between the algebra and geometry, which resulted in the Cartesian coordinate system still widely used today. So, siya yung nakapagdugtong or na bridging the gap between the algebra and geometry, how to plot points on a plane called Cartesian plane. So, sa kanya pala galing yung Cartesian plane na ginagamit pa rin hanggang ngayon sa mga school. I remembered I was Cartesian plane grade 8 or something, grade 9 when I encountered this topic. So, nakaka-enjoy naman siya kasi nagpa-plot kayo ng mga points ng X and Y. Okay? So, according to Descartes, mathematics was the only thing that is certain or 2. So, according to him, mathematics lang daw ang nag-iisang bagay na totoo o yung certain. And the next philosopher that I was shown a while ago on the other slides was Blaise Pascal, 1623 to 1662. Blaise Pascal is a mathematician and inventor of an early calculator. And then, in 1641, at the age of 18, imagine, so bata niya pa, para makapag-invent or makapagsulat ng mga pangmatalinong bagay. Pascal built his first arithmetical machine, an instrument which 8 years later he further improved and called the Pascaline. So, nakapag-discover siya ng arithmetical machine, an instrument which 8 years later, after 8 years, ay nag-improve and tinawag niya itong Pascaline. And why Blaise Pascal invented this numerical wheel calculator, or the Pascaline, is the reason behind that is to help his father, by then a French tax collector, count taxes. The Pascaline had 8 movable dials that added up to 8 figured long sums and used base 10. When the first dial, or the ones column, moved 10 notches, the second dial moved 1 notch to represent the tens column's reading of 10. When the second dial moved 10 notches, the third dial hundreds column moved 1 notch to represent 100, and so on. So, may reason pala may dahilan pala bakit niya inimbento ang Pascaline. Pascaline or Pascaline? Okay, I'm not sure about that. Okay, the other contributions of Blaise Pascal was the relate machine. Blaise Pascal introduced a very primitive version of the relate machine in the 17th century. The relate was a byproduct of Blaise Pascal's attempts to invent a perpetual motion machine. The other one is the wristwatch. Okay, relo. Nakapag-invent din pa siya ng relo. Okay, the first reported person to actually wear a watch on the wrist was Blaise Pascal. So, it was reported pala, or sinabi na ang pinakaunang taong nagsuot ng relo was Blaise Pascal. Using a piece of string, he attached his pocket watch to his wrist. Okay, so, using a piece of string, so, manipis lang yun. He attached his pocket watch to his wrist. Okay, he attached his pocket watch to his wrist. So, yung pocket watch niya ay nilagay niya dito sa kanyang wrist. So, for the last part is the conclusion. So, ang lagay ko dito is, in summary, calculus is a powerful mathematical tool that finds application in numerous fields. Its understanding enables us to model, analyze, and predict real-world phenomena, make informed decisions, optimize processes, and comprehend the dynamic nature of various systems. So, the study of calculus has been further developed in the centuries since the work of Newton and Leibniz. So, during those time period na na-invent yung calculus, is na-develop by over centuries. Okay, so nagagamit talaga natin ang calculus sa mga maraming bagay. Sabi nga, understanding, nakakapag-analyze and nakakapag-predict daw ng real world phenomena, and nakakapag-decide tayo. Okay? Okay, so modern physics, engineering, and science in general would be unrecognizable without calculus, which is true naman. So consequently, knowing and applying calculus can greatly enhance our problem-solving abilities and contribute to a deeper understanding of the world around us. This ends our discussion with the birth of calculus. I hope you learn a lot or maybe a little, but you can research more about this topic. So again, I am April Dominic Chifazon, a Bachelor of Secondary Education major in Mathematics, and thank you.
Euler, Fermat, and Descartes. The period covered by mathematicians Euler, Fermat, and Descartes spans the 17th and 18th centuries, and here's a brief overview of their contributions and the time frames in which they lived. Pierre de Fermat, 1601 to 1665. Fermat was a French mathematician and lawyer who made significant contributions to number theory, calculus, and analytic geometry. Fermat's last theorem remained unsolved for over 350 years, until it was finally proved by Andrew Wiles in 1994. Fermat also made important discoveries in the areas of infinitesimal calculus. René Descartes, 1596 to 1650. Descartes was a French philosopher, mathematician, and scientist who is often referred to as the father of modern philosophy. He made significant contributions to both mathematics and philosophy. Leonhard Euler, 1707 to 1783. Euler was a Swiss mathematician and physicist who made immense contributions to many areas of mathematics. He is considered one of the greatest mathematicians of all time. Euler's works spans a wide range of mathematical fields including calculus, number theory, graph theory, and mechanics. These mathematicians made lasting contributions to the development of mathematics, and their work continues to influence and inspire mathematicians to this day. Euler, Fermat, and Descartes each made significant breakthroughs in mathematics. Here are some of their notable contributions. Leonhard Euler. Euler's formula. Euler derived the famous Euler's formula, which relates 5 fundamental mathematical constants. A stands for the base of the natural logarithm, phi and I stands for the imaginary unit, 1 stands for the identity, 0 stands for the additive identity. The formula is given by E raised to identity pi plus 1 is equal to 0, where E, I, and pi are involved in an elegant and unexpected relationship. Second, graph theory. Euler is considered the founder of the graph theory. In 1736, he solved the famous 7 ridges of Königsberg problem, demonstrating the first rigorous proof in graph theory. This breakthrough led to the development of graph theory as a separate branch of mathematics. Pierre de Fermat. Fermat's last theorem. Fermat's most famous contribution in his last theorem, which states that there are no 3 positive integers a, b, and c that satisfies the equation an plus bn is equal to cn for any integer value of n greater than 2. Although Fermat claimed to have a proof for this theorem, no evidence was found in his writings. The theorem remained unsolved for over 3 centuries until it was finally proved by Andrew Wiles in 1994. using advanced mathematical techniques. Next, probability theory. Fermat made significant contributions to the development of probability theory. He laid the foundations for the theory of probabilities, along with Blaise Pascal, through their correspondence on problems related to games of chance. Fermat and Pascal developed the concept of expected value and solved various gambling-related problems. René Descartes. Cartesian coordinates. Descartes introduced Cartesian coordinates, a coordinate system that allows algebraic equations to describe geometric shapes. This breakthrough in analytic geometry unified algebra and geometry and provided a powerful tool for solving geometric problems algebraically. Next, method of doubt. Descartes' philosophical work, particularly in his method of doubt, had a profound impact on mathematics. He advocated for a rigorous and systematic approach to knowledge, which influenced the development of mathematical reasoning and proof techniques. These breakthroughs by Euler, Fermat, and Descartes revolutionized mathematics and laid the groundwork for further advancements in various branches of the discipline. Their contributions continue to shape the way mathematicians think and solve problems today. Most significant contributions. Certainly, here are the most significant contributions of Euler, Fermat, and Descartes. Leonhard Euler. Euler's formula. Euler's formula E raised to imaginary unit pi plus 1 is equal to 0 is one of the most remarkable and widely known formulas in mathematics. It elegantly connects five fundamental mathematical constants: E, the base of the natural logarithm, pi, I, the imaginary unit, 1, the identity, and 0, the additive identity. Second, graph theory. Euler is considered the founder of graph theory. The solution to the 7 bridges of Königsberg problem in 1736 marked a breakthrough in the field. Euler's insight into the properties of networks and the concept of Eulerian and Hamiltonian paths laid the foundation for the development of graph theory as a separate branch of mathematics. Third, analysis and calculus. Euler made significant contributions to the field of analysis and calculus. He developed new techniques for solving differential equations, introduced the notation for trigonometric functions, and extended the understanding of functions and series. Euler's achievements in this area revolutionized mathematical analysis and paved the way for future developments. Pierre de Fermat. Fermat's last theorem. Fermat's last theorem is perhaps Fermat's most famous contribution. Although he stated it without proof, it became one of the most challenging mathematical problems for centuries. The theorem states that no three positive integers, a, b, and c, can satisfy the equation an plus bn is equal to cn for any integer value of n greater than 2. Andrew Wiles eventually proved the theorem in 1994 using advanced mathematical techniques. Second, early development of calculus. Fermat played a crucial role in the development of calculus, along with his contemporary Isaac Newton. He made significant strides in the understanding of tangent lines, maxima, and minima, and methods of finding areas. Fermat's work laid the foundation for later advancement in differential calculus. René Descartes, Cartesian geometry. Descartes introduced the concept of Cartesian coordinates, revolutionizing the way geometry and algebra were approached. By representing geometric shapes using algebraic equations, Descartes unified algebra and geometry into a single discipline known as analytic geometry. This breakthrough opened new avenues for solving geometric problems algebraically. Second, method of doubt and rationalism. Descartes' philosophical contributions influenced mathematics by emphasizing the importance of rationalism and a systematic approach to knowledge. His method of doubt, which sought to doubt everything until reaching indubitable truths, played a role in shaping mathematical reasoning and proof techniques. Third, coordinate systems. Descartes also developed the concept of a coordinate system, which provided a framework for representing points and measuring distances and angles. His coordinate system, based on perpendicular axes intersecting at the origin, is still widely used today in various branches of mathematics and science. These mathematicians made significant and diverse contributions to mathematics, leaving and lasting impact on multiple fields and laying the groundwork for future developments. Most famous philosophers and their works. While Euler, Fermat, and Descartes were primarily renowned mathematicians, they also made notable contributions to philosophy. However, it is important to note that their works in philosophy are not as well known or influential as those of other prominent philosophers. Here are brief mentions of their philosophical works. Leonhard Euler. Euler's philosophical works are relatively lesser known compared to his mathematical contributions. He did write on topics such as metaphysics, epistemology, and philosophy of science, but his philosophical works are not as prominent or influential as his mathematical achievements. Pierre de Fermat. Fermat's primary focus was mathematics, and his philosophical writings were relatively limited. He engaged in correspondence with other mathematicians and philosophers of his time, including Blaise Pascal, where they discussed topics related to probability and philosophy of knowledge. However, Fermat's contributions to philosophy are not considered his most significant legacy. René Descartes. Descartes is widely regarded as one of the most influential philosophers in history, particularly for his contribution to epistemology and metaphysics. First, Meditations on First Philosophy. Descartes' most famous philosophical work is his series of meditations, where he presents his philosophical system and develops his method of doubt. In these meditations, Descartes seeks to establish certain knowledge by doubting all beliefs until reaching indubitable truths, famously expressed in his famous statement, cogito ergo sum, which means I think therefore I am. Second, discourse on the method. In this work, Descartes outlines his philosophical and scientific methodology, emphasizing skepticism, deductive reasoning, and the application of mathematics to scientific inquiry. He discusses his approach to knowledge, the importance of systematic doubt, and his aim to establish a firm foundation for science and philosophy. Third, principles of philosophy. Descartes presents his philosophical system covering topics such as metaphysics, epistemology, and the philosophy of mind. He discusses his dualistic theory of mind and body, the existence of God, and the nature of knowledge. Next, Meditations on the First Philosophy and the Discourse on the Method are particularly notable for their role in shaping the philosophical movement of rationalism, which prioritizes reason and deductive logic as the primary sources of knowledge. While Euler and Fermat made contributions to philosophy, it is Descartes who is more widely recognized as a significant philosopher with works that continue to be studied and debated to this day. In conclusion, Euler, Fermat, and Descartes were prominent mathematicians who made significant contributions to their respective fields. Euler's achievements spanned various branches of mathematics, including graph theory and analysis, and he is widely regarded as one of the greatest mathematicians in history. Fermat is known for his work in number theory and his famous last theorem, which remained unsolved for centuries. Descartes, in addition to his mathematical contributions, introduced Cartesian coordinates and played a foundational role in analytic geometry. He also made significant philosophical contributions, particularly in the areas of epistemology and metaphysics, with works such as his Meditation on First Philosophy. While their contributions to philosophy were not as prominent as their mathematical achievements, Descartes stands out as a philosopher of great influence, shaping the fields of rationalism and epistemology. Overall, Euler, Fermat, and Descartes left enduring legacies in mathematics and, to a lesser extent, philosophy, and their work continues to be studied and celebrated in their respective domains.